How's it going, ladies and gentlemen? Mr. Johnny here again, looking at 20.2 problems. All right, a lot of balancing going on here. So first question is, how many electrons are involved in the reduction half reaction of chlorine to the chloride ion? Well, trick here is that you got to remember that chlorine is a diatomic molecule. It's only going to show up as Cl2. So if it becomes a chloride ion, it's going to be 2 Cl minuses. All right, well, how does it go from chlorine 0 to 2 chlorine minus ions? Well, it's got to gain a total of 2 electrons. Remember that reduction is gaining, so we're going to put the electrons on the left side because it's gaining those. And for each chlorine to go from 0 to -1 is 1 electron each. 2 chlorine atoms, 2 electrons. All right, number 2, what is the coefficient of the permanganate ion in the following equation when it's balanced in an acidic solution? So the first thing that we got to do is go, all right, well, we start with MnO4 minus, and it becomes Mn plus 2. So now the way I remember balancing is we balance whatever isn't O or H, then we balance O by adding water, then we balance H by adding H pluses, and then we balance charge by adding electrons. So it's in that order. First thing, balance anything that isn't oxygen or hydrogen, and everything that isn't oxygen or hydrogen is already balanced. So check. Second step, balance the oxygens by adding water. Well, I got 4 oxygens on this side, so I have to add 4 H2Os on this side. So now my oxygens are balanced. Whoops. All right, check. Next step, balance the hydrogens by adding H pluses. Well, if I got a total of 8 H's on the right, I'm going to need 8 H pluses on the left. Balance my hydrogens. Last thing to do is to balance the charge by adding electrons. Well, I know I got -1 and 8 pluses over here, so it tells me I got a +7 on the left side, and I only got a +2 on the right side. So I'm going to have to bring this charge down by adding 5 electrons on that side, because now the charges will be balanced. So I just did one of the half reactions. That's done, right? I did my 4th step there. All right, so next I got to look at, well, what happened to Br2? I'm sorry, Br minus. It became Br2. So first thing, balance anything that isn't oxygen or hydrogen. So Brs. Well, I'm going to need 2 Brs if I'm going from Br minus to Br2. So I need 2 of those. Balance oxygens, done. Balance hydrogens, done. Balance charge with electrons. All right, well, I got 2 minuses over here, and I got a charge of 0 over here. So I'm going to have to add 2 electrons on that side, on the right side, to balance the charges. Now, the question is, what is the coefficient for the permanganate ion when the following is balanced in an acidic solution? So, last step in balancing is get electrons lost to equal the electrons gained, right? So, if I'm gaining 5 electrons here but losing 2 electrons here, I'm going to have to do a little multiplying to get everything to balance out, right? What did 2 and 5 have in common? 10. So to get 10 electrons, I got to times the top by 2 and the bottom by 5. So now I distribute all that, right? So let me do that right here. I'm going to get 10 Br minuses. I'm going to get 5 Br2 and 10 electrons. I'm going to get 10 electrons up here, 2 permanganate, 16 H pluses, 2 manganese, and 8 H2O. So when I add all these up together, the electrons are going to cancel out, and I'm left with, what happened? There we go. 2 MnO4 minuses, 10 bromide ions, giving me 2 Mn plus, 5 Br2s, and 8 H2Os. Oh, and I forgot the H's over here. That's the missing thing, 16 H pluses. So that would be my balanced redox reaction. I'm just asking for the coefficient of this thing. So the answer is 2. That's what the coefficient is. Right there, dose. All right, 3, another balancing one. What is the coefficient of dichromate ion when the following equation is balanced? So we got to do the same thing. Might as well start with Fe. Starts as plus 2, becomes Fe plus 3. So this one's really easy. It's just iron. So how did that happen? It lost 1 electron. All right, next, what happened to the dichromate ion? It became just chromate. So we got to do a little balancing. First, balance anything that isn't hydrogen or oxygen. So I got to balance that chromate. I'm going to have 2 of them over here. All right, now we balance oxygens. So I'm going to need 7 H2Os over here, which means I'm going to need to balance my hydrogens. I'm going to have 14 H pluses over here. And now I'm going to have to figure out my charges. I got plus 6 over here, and I got plus 12 on that side. All right, well, I must get, do I have that right? Yep. Sorry, I'm having a brain fart. All right, my brain cleared up. Yeah, so no, I'm doing that right, which means I'm going to have to add 6 electrons onto that side. So now the question is, what is the coefficient in front of this guy? So we got to figure it out. All right, well, in order to get these to balance, I would have to times the top one by 6 because I got to get this to cancel out the 6 electrons down there. What do I got to do to this bottom half reaction? Nothing, just times it by 1, which means what's my coefficient for that guy going to be? It's going to be 1. Didn't have to do anything to it. 4. What is the coefficient of Fe plus 3 when the following equations balance in a basic solution? All right, so basic solution follows a lot of the same steps, except there's one last step. So 1, balance anything that isn't oxygen or hydrogen. 2, balance the oxygens by adding water. 3, balance the hydrogens by adding H pluses. 4, balance the charge by adding electrons. Next step, do the half reactions to cancel out the electrons lost and electrons gained. And then what you do is you got to neutralize the H plus by adding OH minuses to make water. All right, so let me show you what I'm talking about. So first thing, let's start with that Cn minus. It's got to become CnO minus. So first step, balance everything that's not oxygen or hydrogen. That's already done. Balance oxygen by adding water. So I'm going to have to add H2O over here. Done. Balance the hydrogens by adding H pluses. All right, so plus 2H plus. That's not how you draw an H. There you go. I got an eraser. I'll just use the eraser. Done. Balance the charges by adding electrons. Well, I got minus 1 over here, and I got plus 1 over here. So I'm going to have to add 2 electrons to this side so that the charges cancel out. Right, because this says minus 1 right here. Cool. All right, and awesome. Now I'm going to do that for the other half reaction. We got Fe plus 3 becoming Fe plus 2. How did it do that? It gained 1 electron. All right, so now how do I get these to cancel out? Where I'm losing 2 electrons here and I'm gaining 1. So I'm going to have to do this bottom reaction twice. So I double the whole thing. Now I can add them together with the electrons canceling out because 2 lost, 2 gained. So now I got Cn minus plus H2O plus 2Fe plus 3 giving me CnO minus plus 2H pluses plus 2Fe plus 2s. So I've done the first 4 steps. Now I did the 5th. I had the half reactions cancel out. Now if it's in a basic solution, this H plus isn't going to really be there. It's basic. H plus is an acidic thing. So we got to say, hey, we got to get rid of these H pluses. How do we do that? Well, we're going to have to add 2 OH minuses to both sides. Because what's going to happen to the H plus and the OH minus on this side? They're going to combine to become 2 waters, 2 H2Os. Now, one thing you got to be careful of, there's an H2O on the left and 2 on the right. So it's going to cancel out that H2O and cancel out one of these H2Os. So what we're going to be left with is this. Right? And you know what, let me make that neat. I'll just rewrite it up here. H2O plus 2OH minus. I can erase that. Now it's nice and neat. The question is, what is the coefficient of Fe plus 3? Well, you can look, Fe plus 3 is 2. So the final answer is 2. Right? To get the coefficient, you didn't have to probably do all those steps, but it's, you need to be able to do all those steps. 5. How many electrons appear in the following half reaction when it's balanced? So, write it out. First step, balance everything that isn't oxygen or hydrogen. So I got to balance sulfurs. I'm going to have to put a 2 in front here, so I end up with 4 sulfurs on the left and 2 times 2 sulfurs on the right. Right? Now it says balance the oxygens. Done. I got 6 on the left and 2 sets of 3 on the right. Balance the hydrogens. There are none, so it's balanced. Balance the charge. Oops, I forgot the charge over here. Well, I have -2 on the left and -4 on the right. All right, well, how am I going to change that? I'm going to have to put 2 electrons on the left side. So now it's -4, -4. So I've now balanced the electrons, and I'm done. So the question is, how many electrons appear in the following half reactions when it's balanced? 2. 2. That's it. Right, 6. The balanced half reaction in which the sulfate ion is reduced to the sulfite ion involves how many electrons? So the first thing is you got to go, hey, what are these things? Sulfate, SO4 minus 2, and sulfite, SO3 minus 2. So it's going to become that. So again, first thing, balance everything that's not oxygen or hydrogen. That's already done. Balance the oxygen. So I'm going to need an H2O. H2O on that side. So I have 4 oxygens on each side. Balance the hydrogens. So I'm going to have to add 2 H pluses on this side. Done. Now balance the charge. Over here I got a charge of 0, and over here I got a charge of -2. So I'm going to have to add 2 electrons on that side. So the question is, how many electrons? Again, the answer is 2. And the last one, balance the following equation in an acidic solution and determine the coefficient of H plus and its location, right or left side of the equation. All right, so let's start. All right, we got Cn minus becoming AgCN. Actually, you know what? This is probably easier just to be like, hey, all right, well, this oxygen, where did it end up? Well, I know I balance oxygens by adding water. So I'm going to add 2H2O on this side. Oxygens are good. But now I have to balance using the hydrogens. So I got to add 4H plus onto the left side. And now I think everything's balanced now. All right, let's check. We got carbon, nitrogen, silver, oxygen, hydrogen. On the left side, we got 4 hydrogen, 1 carbon, 1 nitrogen, 1 Ag, and 2 H's. On the left side, we got 1 carbon, 1 nitrogen, 1 silver, 2 oxygen, and 4 hydrogen. Awesome. So that's the answer. 4, and it's on the left. That's it. See you in class. Bring questions.